ourselves and we pray. Good Lord, we know you love us and always you are with us. Enable us as we gather for this lesson. May you make us good critical thinkers to use our minds for your greater glory. Enable our teacher. As students, may you enable us to be active so that we may get what we are going to be taught. Amen.
Amen. Thank you very much, Nusra, for that wonderful prayer. I want to welcome each and everyone who has joined us to this session. This is our fourth lesson in this year 2026. And as I told you last time, today is our last day to tackle oxidation and reduction reactions. So last time we met, we didn't complete our work about electrolysis, and today we shall be continuing from where we stopped so that we can accomplish this, and we also learn more as we get done with this topic. As usual, I want to request us to keep on raising up the hand, and we keep on discussing so that we are very active to make this session very good. Allow me to work on these people who are trying to write on our screen, and then we shall be able to begin. Okay, that is okay. Now, let me have one person raise up the hand and you tell us what we looked at last time, and we move on very fast. Who is ready to take us through? You're going to remind us with this question where we ended, and you tell us what, maybe number one, you tell us what you know about number one, and then we shall be going to number two for those who attended our previous session. Who is ready to today to lead us in this scenario? By show of hand. Who is ready? Okay. Galax, you can unmute. Yes, Galax, unmute. Galax, unmute. Then even AANN, you can unmute. You are going to have the two people. Galax, are you there?
Yes, please, teacher.
Okay, now take us through that. I believe that's where we ended last time, and I want us to pick it from there and we move on faster. So the scenario says that we pass electricity through molten sodium chloride. I believe for those who are joining us for the first time, we are still looking at our topic, which is oxidation, reduction, and reaction, and we are looking at our subtopic, which is electrolysis. Maybe if you can you first remind us what electrolysis is before you answer these questions?
Electrolysis is the breakdown of an ionic compound in solution or molten form when electric current is passed through it.
So we are seeing the key ones here: ionic compound, and we are passing electric current through it. And we are saying that when you pass through that compound, we break it down by use of this current. We're saying that is what you're calling the electrolysis. And here is this scenario where we ended. And we are saying that if we pass electricity through molten sodium chloride, the word is molten. So we said we have two words, molten, and we also have aqueous. Can you first help us understand what does molten mean and what does aqueous mean? Let's move on. Yes, please, move on.
Aqueous means dissolved in water.
Okay, dissolved in water. Okay. Then molten.
I think molten means broken down into solution state.
Being broken down into solution state, maybe by the presence of heat. Maybe we are melting it into liquid. So that is the one we are calling molten. So when we pass electricity through molten sodium chloride, which ions are present? Now we've been very fast. We are going to take us through number 1 and 2, and then the other one, 3 and 4. Okay.
The sodium and chloride ions are present.
Sodium ions and chloride ions are present. Okay, good. Where are these ions coming from?
Sodium chloride.
From the ionization of sodium
Okay.
chloride, where it breaks down to form the sodium ions and the chloride ions. And we say that because it is molten, meaning here we are not having water, instead we are heating this one, and then it forms, changes to the sodium ions and then the chloride ions. Therefore, in the ions present in this state, we are saying we have only the sodium ions and the chloride ions. So which ions go to the cathode?
The sodium ions go to the cathode.
Why?
Because negative and positive charges attract, and since the cathode is negative, so the sodium ions which are positive move towards the cathode.
Very good. Can you clap hands for her? That is, what is your name? You have AA and NN. What is the name?
Which I'm fine with you. I'm fine with you calling me that.
AN. Okay. Melvin, thank you very much for leading us in number 1 and number 2. Now let's have Melvin also take us through 3 and 4. Yes, Melvin.
Good afternoon, sir.
Good afternoon.
So, sir, number 3, what happens at the cathode? So I think reduction happens at the cathode.
What happens?
Reduction.
Reduction. Can you explain why reduction, not oxidation?
Because at the cathode there is gain of the sodium ions,
There
which
is
are
what?
positively charged. Gain of the sodium ions, which are positively charged.
Gain of sodium ions which are positively charged. So is it the reason why we have reduction?
Yes, sir.
Okay. So because we say that reduction, that is the gain of electrons. Yeah, gain of electrons. But we are seeing that at the cathode, we are seeing the sodium ions going there, meaning since they are going there, they are going to be discharged, and the only way they can be discharged it's by adding an electron to this sodium ion. So when you add an electron, that is what we are calling reduction. Are you seeing that?
Yes.
Okay, good. So what is formed at the anode?
So I think it's chlorine gas.
Chlorine gas. Okay, thank you very much. And I believe last time we were able to go through the video which was showing us the setup for electrolysis of aqueous sodium chloride. Thank you very much. You can mute, and then we have another person who's going to lead us through another set. Everest, you unmute.
Sir,
Yes, please.
you're not audible. I'm not hearing.
Oh, sorry. Is it only you or any other person who is not hearing very well?
I think it's our first time.
Okay. So for you, you're getting me clearly. Nusra, can you hear me very well? Nusra?
Yeah.
Okay. So Everest, you can check, maybe you can increase on the volume on your side and it will be very clear.
Okay, sir.
Okay. Do you have, so Everest, you leave your microphone on and then we go through this setup for sodium chloride. So that is, now the one we have been talking about, this one is molten sodium chloride. And now this time round, we want to look at the aqueous sodium chloride. So when you talk about the electrolysis of aqueous sodium chloride, we see some of the materials that we need. Number one, we are saying we need sodium chloride itself, crystals. We have carbon electrodes. We have the dry cell with battery holder. The bulb, like we said last time, this bulb is not a must, but we can put it so that we test whether the current is flowing or not. And then we have also a switch. Then on what to do, Everest, you can read for us from A to D, these procedures. Yes, Everest?
Place a sample of sodium chloride in a beaker.
Mm-hmm.
Dissolve it in water.
Mm-hmm.
Arrange the circuit with 2 electrodes and bulb as shown in the figure below.
So the figure, we are having this which we are using on the side, okay?
Complete the circuit and state your observations.
Complete the circuit and show the observations. So we are having this, so we have this electrolysis for aqueous sodium chloride, and we are going to discuss a few questions. What happens at the cathode? What happens at the anode? And you recall that this time round, it is aqueous solution, meaning the ions present, we are going to find out that the ions present in the solution are different. But because we had this the other time, we are going to just go through it, and then we shall be starting with our practice item, which we are going to look at later. So we're saying, when we look at the first stage, we are saying that we have the ionization in solution. So because we have sodium chloride, which is aqueous, meaning that we are going to have sodium chloride, we dissolve it in water. And when you dissolve it in water, even water is also going to slightly ionize. That's why we see that there is a partial ionization of water, giving us also the hydrogen ions and the hydroxide ions. Then sodium chloride, for it is ionizing completely to form the sodium ions and the chloride ions. Meaning in the solution, we have all these ions present. The sodium ions, we have the chloride ions, we have the hydrogen ions, and then we have the hydroxide ions. So we can see these are now the ions present in the solution, yet at first we saw that we had only the sodium and the chloride. But because this one has been dissolved in water, that's why we see that we have the sodium ions, chloride ions, the hydrogen ions, and the hydroxide ion.
And
That one is clear? Yes. Everest, is it clear?
yeah,
Okay, now we say that which ions move to the anode and which one move to the cathode. So you can take us through part A, reactions at the electrodes. Take us through part A, and then Galax is going to take us through part B, and then Ria will also unmute and take us through the remaining. Yes, take us through part A as you explain to the members. Galax will be the next, don't worry, and Ria. Yes, please.
teacher, actually, this is my first lesson this is my first time to attend this lesson, so I'm trying to catch up.
Oh, it's okay.
Yeah.
But the full session is on YouTube. You go on the holistic platform, you'll find the previous lessons. Then you can be able to catch up more. But even from here, if you have any question, you keep on asking so that you can be able to move along.
Okay.
Okay, let's have Galax. You can mute and then you have Galax. Galax, Ria, Ria, you unmute.
Yes, teacher.
Take us through part A and you help these people who have joined us today to understand what is happening
Teacher,
at this.
I'm going to try because I'm not very familiar with the lessons also.
Okay, you're going to do what?
To try.
Yes, please.
So it says at the anode, positive electrode, carbon. So all I know
Uh-huh.
is that at the anode, an anode is a positively charged electrode, and
Okay.
at the anode, the negative metal ions are attracted at the anode since unlike poles attract.
And the negative metals are not negatively charged, but it is negatively charged what? Ions, isn't it?
Ions, yes.
Okay.
Teacher, there's a lesson you said via metal ions, something like that.
The metal ions are attracted to the cathode.
That means the anode doesn't have metal ions
No, the anode,
because
it is,
they're negative.
yes, and we don't have any metal which is negatively charged.
Okay. So chloride ions and hydroxide ions are attracted because they are negatively charged, and
Okay,
chloride
good.
is preferentially discharged because it has a lower discharge potential than hydroxide. So because chloride is it has it has a lower discharge, the potential is lower than for hydroxide, so it is left like it's discharged before the hydroxide ions. Then oxidation reaction. So the screen has been blocked, I'm not seeing. Yeah. Oxidation reaction occurs. Um, so that's all I can take you through.
Okay, thank you. So I believe, is there anything which has not been very clear? Because I was saying that in the solution you have sodium ions, chloride ions, and hydrogen ions and hydroxide. But you can see that the chloride and hydroxide are the ones which are negatively charged. And because we have the anode which is positive electrode, meaning these negative ions are the ones which are going to be attracted towards the anode. So that's why we're having the chloride ion and the hydroxide ion being attracted to the anode. But now, the discharge depends on which one is more reactive and which one is less reactive. So when you look at these negative charged ions, we have the reactivity series of anions, or the negatively charged ions, and we are saying that the chloride ion is less reactive than hydroxide, meaning it will be preferentially discharged compared to the hydroxide. So, which means chlorine, when it is discharged, automatically now it will be discharged to form the chlorine gas. And therefore, the product we're getting, we are saying it is chlorine gas, and it is seen with the bubbles which are given.
Excuse me, sir.
Yes, please.
So you said chlorine ions are less reactive than hydroxide.
Yes.
Sir, how
That's
are the
something
less
I'm going to.
reactive ones discharged faster? I thought the ones that react faster are the ones that get discharged before the less ones.
Okay. No, the lower, these ones which are lower in the reactivity series are the ones which are discharged compared to the ones which are more reactive. That
Teacher,
is
you're looking
in
at the
the
arrangement.
electrolysis. I believe that's how, yes, the arrangement of
Okay.
anions and the arrangement of the cations. And now this time we're looking at the anions. If you look at the
Yeah.
arrangement of anions, the chloride ions are lower compared to the hydroxide ions in the reactivity cell of anions.
Yes.
Yeah. Therefore, the ones
Yes.
which are lower are the ones which are preferentially discharged. When you say
Discharged.
preferentially discharged, we are removing this charge. And the only way we can remove this charge is by adding an electron, because the negative charge, it shows that it has extra electrons.
Electrons. Yes, sir.
Yes. Okay, thank you. Let's have, thank you, Ria. Let's have Jeremiah now. Jeremiah?
Yes, teacher.
Take us through part B.
Part B. At the cathode, in brackets, negative electrode or carbon.
Now,
Sodium.
the carbon, maybe to speak something small, when you see carbon, here we're meaning that we're using the electrodes of carbon. Are we there? Even here we're using electrode of carbon. But this one is anode, because it is positive electrode, and this one is cathode because it is a negative electrode. And last time we were able to learn how we are able to identify the negative electrode and the positive electrode. We are going to use like 2 minutes after here to see the other video again for the last time. Yeah?
Yes.
Okay, continue.
Okay, sodium ions and hydrogen ions are attracted. Like the sodium and hydrogen ions are attracted to the cathode because they are positively charged ions, and the cathode is negatively charged, so like they'll be attracted. And then hydrogen ions are preferentially discharged over sodium because they are lower. They have a lower reduction potential. Reduction reaction occurs.
So
hydrogen
when you look
ion.
at, so the hydrogen gas is the one which is given out, and we see this by we see the bubbles which are given off. And we are saying that at the cathode, it is reduction reaction which is taking place.
Yes.
While at the anode, it is oxidation reaction which is taking place.
Yes.
Why are we saying it is reduction? Because these are positive ions coming, and the positive means that they have lost something. Therefore, for us to make it stable, we need to add the lost electrons. So that's why we see addition of the electron, and we call that one reduction. Is it clear?
Yes.
Okay, thank you, Jeremiah. Let's have Hey.
I said, teacher, I have a question.
Yes, please.
On the thing of preferential discharge, like I'm not yet fully understood its meaning. Does it mean like hydrogen is more
Lower.
likely to be is lower?
Like when we say that hydrogen is preferentially discharged, meaning when we look at the reactivity series of the different anion of different cations, the positive charged ions, you'll find that hydrogen is lower than the sodium ion. I'm going to bring that immediate after here. That's what we're going to look at. Before we look at the electrolysis of sulfuric acid, before we look at electrolysis of copper 2 sulfate, I want us to first understand that the discharge, which one is discharged, which one is not discharged. So those are the things I want us to look at immediately after this page here.
Okay, thank you.
Yeah. Okay. Make sure you have where to write so that you can be able to note down that.
Yes.
Okay. It's all right. Now you can mute, and we have bracing. Bracing.
Teacher, I was asking if you could like repeat explaining because I just joined. Yeah.
Which one should I explain first?
I think the whole thing because I just joined and I'm not understanding what's going on.
Okay. But what you're going to do, we are having this, then I'm going to put the video and you watch it. What we are looking at here, it is going to be shown in the video, which you're going to watch for just around 3 minutes. Yeah.
Okay.
And I believe you'll be able to get it. If not, you'll be able to ask where you have not understood. But keep your microphone on. I first let you know something small. we said here it is electrolysis of aqueous sodium chloride. We said so aqueous means that the solid has been dissolved in water. So when you say aqueous sodium chloride, we are dissolving sodium chloride in water. Now, which ions are present? So that's why you see here on ionization, we are having sodium chloride ionizing to form the sodium ions and chloride ions. Then even water will also slightly ionize to form the hydrogen ions and hydroxide ions. Now, what does it mean? Which means in that solution, we're having these ions. Bracing, are you seeing them? The sodium
Yes.
ions, chloride ions, hydrogen ions, and hydroxide ions. These are the ions present in the solution. But now, when you pass in electricity, what happens? We have the electrodes, and we say that electrodes are called the conducting. These are conducting loads. They conduct they are the ones which help in the movement of the electrons and the current. So they are called conducting loads. Now we have two loads. Number one is called the anode, which is the positive electrode. And we have also the one we call the cathode, which is the negative electrode. Now the positive electrode, because it is positive, and in the solution we have positive ions and negative ions, those ones which are negative are attracted towards the anode because it is positive. Are we together? So, bracing,
Yes.
are we together on that point?
Yes.
Yeah, so because anode is positive, we are going to have the chloride ion and hydroxide ion be attracted towards the anode. But now they can't all be discharged at the same time. Instead, the one which is lower in reactivity is the one which is preferentially discharged. So that's why we say that the chloride ion are preferentially discharged because they are lower. They have a lower discharge potential, or they have a lower reactivity compared to hydroxide. And then we have that reduction reaction taking place. And then the same case will happen on the cathode. Because it is positive electrode, which means, negative electrode, meaning the positive ions will be attracted towards it. That's why we're having sodium ions and hydrogen ions, which are positive. But now we find which one is going to be discharged. And we are saying that it is hydrogen. Why? Because for hydrogen, it is lower in the reactivity, and therefore it will be discharged, and we see that it is undergoing reduction reaction. Now, finally, we want to look at the overall equation. Of course, when we look at overall equation, now that's what we call a redox equation, because this is a redox reaction, and so because it has both the one equation for oxidation and also the one for reduction. That's the one we call the overall reaction, which is a redox reaction. So they have combined all the two, and they are giving us our product, which is here. This is our overall equation. But it may confuse us how it came about. But for us, if we want to make it very easy for us to see, we can just get the oxidation, which is our half equation at oxidation, which is 2 chloride ion, giving us chlorine gas plus 2 electrons. And then we have, for reduction, where we have 2 hydrogen ions. We are adding 2 electrons, and it is giving us hydrogen. So when it gives us hydrogen, we can say we add these two equations. So when you add these two equations, what happens? Which means we'll be having 2 chloride ions. We are adding this one, 2 hydrogen ions. We are having 2 electrons this side, giving us chlorine. How we are adding hydrogen. Then we are having 2 electrons. But now, because these 2 electrons are both sides, they can easily do what? Cancel. Are you seeing that?
Yes.
So which means finally, we shall be having 2 chloride ions. We are adding 2 hydrogen ions, giving us chlorine, and we have the hydrogen gas. And this one can be our overall equation. So when they ask us to write the overall equation at any point, what they want is just getting the one for oxidation. We add it to the one for reduction. And when we have these ones, we are able to have a redox reaction, which gives us the overall equation. I want to see if there's anyone with a question, or I should take her through the explanation for how the discharge comes about, or how this one comes about, the preferentially discharged species. Let me see if there's any person with a question. Crystal, you have a question? Crystal, unmute.
Yes, teacher.
Yes, please.
Oh, teacher, I understand that the anode is like the positive electrode, and yes, this is where oxidation takes place. But teacher, since oxidation is the loss of electrons, then wouldn't it mean that now, like, because it's positive, then it needs to gain more electrons, like at the positive electrode?
First,
I'm a bit
now,
confused on that.
oh, don't worry. We are saying that an anode is positive, is a positive electrode. Yeah, are we there? Hey, hello, Crystal, you have gone. Okay, so anode is a positive electrode, and we're saying that at the anode, because it is a positive electrode, the negative ions are the ones which are going to be attracted. Now, when the negative ions are attracted, anything which is negatively charged, for example, if you say this is our ion with 2 minus, this 2 minus means that it has gained 2 extra electrons. Because it has gained 2 extra electrons and we want to discharge it, we want to remove that charge, which means for us to make it stable, we need to add 2 electrons. Hey, we need to remove minus. We need to remove 2 electrons so that it is discharged. So we can write it like this, or we have it as 2 minus, and then instead of putting their minus, we put the 2 electrons this side. And we said that whenever we are removing electron, then that is what we call the oxidation. Oxidation is the removal of electrons, while reduction, we said, is the addition of electrons. We should not forget our oil rig. The oil rig. Okay, and the oil rig, what do we say? Oxidation is loss, reduction is gain. So that is the one which I want us to always use, at least to recall if we have forgotten which one is the gain of electron and which one is the loss of electron. Crystal, let me know whether you have a question. Ria, you have a hand up. Unmute.
Yes, teacher.
Any question?
Yes, I am a bit confused. Like you've said that so I want you to approve if what I'm thinking is right. You've said that like oxidation is the loss of electrons. So
Good.
if maybe I am using sodium ions, and this one is going to lose 1 electron, meaning it's a metal and it's positive. So you determine which electrode will get discharged from according to what you'll do to make it stable. Since it's losing, so the loss of that 1 electrode is going to make it stable. That means it goes under it will be discharged by the anode.
Now, when you look at the sodium ion, it is positively charged, isn't it?
Yes.
So, which means for the one which is positively charged, when the electrolysis stands, when we pass this current, or when the current is passed through the solution, the positive ion will be attracted the electrode which is negative, that is the cathode. It will move towards the cathode. We say that the opposite charges attract one another. So because this electrode is positive, is negative, and in the solution you have positive ions, for example, the sodium ion, which means it is going to be attracted towards the what? The cathode.
Teacher, now what
Are
will
you
you
seeing
call that? That is oxidation.
Now, when it comes to the cathode, are you there?
Yes.
Let's move together. When it comes to the cathode, it has to be discharged. And for us to discharge this sodium ion, because it is having a positive means that it had already lost an electron, one electron. Are we there? So
Yes.
for us to discharge it, we need to add one electron, like the way we have done. So when we add one electron, meaning addition of electron is called what? Reduction.
Addition. Yes.
Are you seeing? Which means at the
Yes.
cathode, reduction is the one which takes place. Because at the cathode, that's why the metal ions are attracted. These sodium ions and other positive charged ions. But when you talk about the anode, it is oxidation that is taking place because the negative ions which are going there, and for them to be discharged, we need to remove electrons. Is that
Teacher,
clear now?
not yet. So teacher, you said as the sodium ion will go to the cathode. So to make, so it will be, because it will later need to gain an electron to become stable.
But now you recall, first look at this. The sodium ion here and hydrogen ion are all being attracted. Are we there?
Yes.
But which one is to be discharged? There are two ions which are going there, but we need to find out which one is going to be discharged. And we are saying that between the two, sodium and hydrogen ion, between the two, it is hydrogen ions which are going to be preferentially discharged. Why? Because for them, they are lower in the reactivity status. So the ions which are lower in the reactive status are the ones which are discharged. So in this case, instead of discharging the sodium, we are discharging the hydrogen ions. Are we there? Are we there on that? Hello? Okay. Crystal, let me hope now you're clear. You can unmute. Crystal?
Teacher, I just want to make sure that I've understood. So at the cathode is already negatively charged, meaning that it needs
Yes.
another electron. So that's why reduction is the one that takes place there.
First wait. At the cathode is negative charged electrode.
So meaning that it's how do I say?
Meaning
That okay,
the positive ions are going to be attracted towards it. Positive ions. Now, when the positive ions come towards it, there is one positive ion that is going to be discharged. Are we there?
Yes.
Now, for you to discharge a positive ion, you need to add an electron, because having a positive means that it had already lost something. So for us to make it stable, we need to add an electron. And we say that addition of electron is what you call reduction.
Reduction.
And I said this experiment can be done at home. Let's look at the other video again for the last time at least. I believe, tell me whether you're seeing clearly. Are you seeing clearly there? Now,
yes.
You let me know whether the sound is clear. Is it clear?
Not a lot. I can't hear. I still can't hear.
Is it clear? You can't hear.
Okay.
Oh, okay. Maybe let me just show us. So here we are seeing here the power source. Just this is exactly what we saw the other side. So, and they are trying to do the electrolysis of sodium chloride. This is the common salt that we use for cooking. And what I was saying, we need the power source, and here we have just joined the 4 batteries, and they are telling us the reason why they have joined these ones to increase the voltage just because each battery can release 1.5 volts. So they increase it so that the current can be much a little bit. Then here there is a beaker which is having water, and they are going to add in sodium chloride and they dissolve in this solution. This one we are seeing here, those 2 pieces, those are the carbon electrodes. In our next video, which we are going to watch for copper 2 sulfate, for it we have used a pencil. We can use because you call a pencil, that one we used for writing, that pencil lead is made of graphite, and you recall graphite is composed of only carbon. So we can even use that one. So if you don't have this carbon electrode at home, don't start moving up and down. Just get your pencil, sharpen both sides. We are going to show you in our next video, and we shall be able to see how we can utilize the available materials. Now, then these are copper wires. These are copper wires which are just helping in the transfer of electrons and transfer of the current. Then these ones we're seeing here, this one here, the red and the blue, these are crocodile clips. Crocodile clips are the ones we are going to attach. You recall here they are metallic, so they help in conducting the electricity through from this copper wire to the electrode. So that's the importance of these crocodile clips. I believe I can make it move on, and then we see. Uh-huh. Okay, so that is our switch.
Master,
Yes. Yes.
I think we are not hearing anything from the video.
Oh, there's nothing that is coming out.
Yes.
No, teacher.
Okay. It's all right. But I believe we have been able to see the materials that we can use, and I believe we can be able to connect, and then we do the same thing wherever we are. It's all right.
Okay.
We can move on to another part to explain. I want us to look at now, how do we understand that? How do we understand that this one is the one which is more reactive, and this one is the less reactive? Read for us. Here they are saying reactivity cells of radical ions. Radical ions, and these ones you call, we are saying that the radical ions based on discharge, discharge preference in electrolysis. We have been seeing that at the anode and at the cathode, if we have 2 ions which are going at the cathode, 2 ions which are going at the anode, there's that ion which we say that is preferentially discharged. And we want to see, where do we get all that information? It is got from the reactivity series. So today we want to look at the reactivity series of cations, reactivity series of the anions, and then we see if we have different ions, which one can easily be discharged and which one can easily be, which one is not easily discharged. Read for us that paragraph here, and then we can move faster. Yes? Read for us. Okay. Bracing, you can read for us. Blessing. Blessing. Okay. Jeremiah.
Yes.
Yes, please.
So, reactivity series of radical ions based on discharge preference in electrolysis. In
Okay.
electrolysis, ions are discharged based on their position in the electrochemical series. The reactivity series for radical ions, in brackets, anions and cations, determines which ions are discharged preferentially at the electrodes.
First pause that. So I'm saying that the reactivity series of radical ions, the radical ions, they can be positive or they can be negative. So we have the anions and we have the cations. So that the reactivity series is the one which determines which ions are discharged preferentially at different electrons. We have already seen in the previous session where we are looking at the anode and also looking at the cathode. You find that at the anode, because it is a positive electrode, we saw that we are having maybe in the previous session, we had negative ions coming towards this. We had chloride ion and the hydroxide ion. But between the two, there is the one which is preferentially discharged. At the cathode, we had hydrogen ions and sodium ions. Between these two, we are able to see which one is preferentially discharged, but they don't just get it. Instead, they use the reactivity series to determine which one is to be discharged and which one is not supposed to be discharged. So that is the one thing that we are looking at in this session here. So we are saying that number one, the reactivity series of cations, the positive ions. And we say that the cations, these are the ones which are attracted towards the cathode electrode. So what are they telling us? That the least is easily discharged compared to the most. It is moving from the least to the most, and the one which is least is easily discharged compared to the one which is more reactive. So it is from the least and also moving to the most, which is easily discharged. So look at this simple table here. I just want to put the whole table on the screen so that you can be able to see. Let me hope we can be able to see that table at that point. So here we have a list of cations. And here they're telling us ease of discharge. Ease of discharge. So here we are saying we have the positive, the potassium, sodium, calcium, magnesium, aluminium, hydrogen, copper, and then silver. So at this, they're saying that more easily discharged than metals above. Here they're talking about the hydrogen. If you have hydrogen and any of these metals, hydrogen becomes more easily discharged compared to all these ones which are above. Then when you move down, copper will easily be discharged compared to hydrogen. Why? Because it is lower than hydrogen. When you go to silver, it is more easily discharged than hydrogen. Why? Because it is lower in the reactivity series. So we're saying that the lower in the, if the any substance, the ion is in lower in the reactivity series, therefore it will easily be discharged. I want to see whether we have any inquiry, any question at that point. Jeremiah, do you have a question?
No.
Okay, good. Ria?
Teacher, what's the difference between electrochemical series and reactivity series?
Okay. Electrochemical series and reactivity series. Okay, there's someone who wants to answer you. Senyondwa. Frederick. No, he has put down Precious. Yes, Precious. Your answer here. Yes, Precious. Precious, you're not very clear. Precious, you're not clear. Hey, there's someone who is having a hand and is called Hey. Hey, you unmute.
Good afternoon, teacher.
Good afternoon.
Teacher. So, I think reactivity series is the arrangement of metals according to how fast they react. According to how fast they react. And then the electrochemical series is how fast is the arrangement of ions according to how they are discharged. I think, yeah, from the least easily discharged to the most easily discharged. Then, teacher, I have a question. Teacher,
Before you go, before you ask,
they say
let's
that.
first know whether. Hello, hey. First, wait.
Yes, teacher.
See whether Ria has understood that one.
I've
Ria,
not
are you okay
understood.
with? Okay, hey, please pardon that.
Okay. Reactivity series is the arrangement of metals. The arrangement of metals.
So reactive series is specifically talking about the arrangement of the metals according to their. Hey has disappeared. So it's telling us reactive series. If you call when you're looking at reactive series in senior 2, we are looking at the list of metals which are ranged from the most reactive to the least reactive. Yeah?
Yes.
Do you recall that? And then when you talk about the electrochemical series, electrochemical series, here we're looking at the list of elements or ions. Elements or ions. A list of elements or ions arranged according to their standard electrode potential values or according to their standard electrode potential. And when we talk about standard electrode potential, it shows the tendency to gain or lose electron under standard conditions. Are you getting that?
So in electrochemical series, that's why hydrogen is included, because it's not for only metals but all elements, and then reactivity is only for metals.
Reactive series is basically for metals, but you recall also in reactive series, we include also the hydrogen is there and the carbon is also there, which are not specifically metals, but because they are commonly used, the ones which are included. But majorly, reactive series is a list of metals according to their reactivity from the most reactive to the least reactive. And this one is based on how easily they lose electrons to form positive ions.
So
the reason why we
arrangement is the same.
Yes?
The arrangement is the same in electrochemical and reactivity.
And you recall, in reactive series, the arrangement is based on how easily they lose electrons to form positive ions. That reactive series for metals. Are we there?
Yes.
Are we there? Now, when you
Yes,
come
teacher.
on electrochemical series, we are looking at, it shows the tendency on how they gain or lose electrons. So still, you'll find out that the answer, the arrangement here for these metals is the same, because even from the definition is almost also the same, because for electrochemical series, for it is basically looking at It can be either elements or even ions arranged according to their standard electrode potential or arranged according to how easily they lose or gain electrons under standard conditions.
Okay.
Yes. So it's the same thing, only that for reactivity studies is basically looking at the loss of electrons to form positive ions. While for electrochemical studies, it is due to loss and gain. That's why we're looking at the series for cations. We're also going to look at the series for anions, the positive charged and also for the negative charged.
It's I've tried to understand.
And before you go, so when we have in the
Yes.
solution, let's look at this. If in the
Yes.
solution you have hydrogen ion and copper ions as the positive ions present, and all these are going towards which electrode? Where are they attracted to?
To the cathode.
To the cathode, because they are positively charged. Between the two,
Yes.
which one will be preferentially discharged?
High copper.
Why?
Because it has it's like its reactivity is less than the one of hydrogen.
Yes, because it is lower in the reactivity than hydrogen, which means for this case, you'll be having copper because it is having a positive 2, meaning it lost some electron. For it to become stable, it is going to gain 2 electrons and then it is discharged to form copper solid. And we are not going to talk about hydrogen. Are you seeing that? Are you seeing how this one
Yes.
helps us? So when you have
Yes.
hydrogen ions and copper ions, that's how this reactive cell is going to help us. We know that actually the one which is lower will be discharged, will be preferentially discharged at that particular electrode.
Okay, sir.
Okay. So you read for us this statement before you go. That rule that we normally follow.
In aqueous solutions, hydrogen is usually discharged instead of more reactive metal ions, for example, sodium, potassium, calcium. However, less reactive metals like copper and silver are discharged preferentially.
Let me hope that one is very clear.
It's not.
They're saying that in aqueous solution meaning we are having in a solid which has been dissolved in water. Are we getting that? So
Yes.
when you have that aqueous solution, they are saying that always you'll find out that hydrogen is usually discharged instead of the more reactive metals you see from the reactive series. Hydrogen is here and these reactive metals are up, meaning the hydrogen is lower in the reactivity than these metal ions. So that's why they are saying that it will be discharged preferentially compared to these ones.
Yes.
Are we there?
Yes, sir.
Yes. So then but however, less reactive metals like copper and silver are discharged preferentially. And that's what you have already told me, that if you have copper and hydrogen ion, copper will be preferentially discharged. Why? Because it is lower.
Okay, sir.
Okay. Let's have now another person. Precious. Okay. Precious or Jonathan Nelly. Jonathan Nelly?
Yes, hello.
Yes. Any question or you take us through number 2?
It's a question.
Yes.
It's a question, sir. So during the manufacture of sodium hydroxide, there is some electrolysis there, and among the elements or the atoms that go to the cathode is sodium, and because we carry out electrolysis on brine, sodium chloride. So sodium and hydrogen go to the cathode, And as if I have not forgotten, sodium is the one that is sodium is the one that is preferentially discharged, and that contradicts with what you're saying in this rule in aqueous solution. So it kind of confuses me.
Okay, I like that. And actually, you keep there. Don't go anywhere. Yep. Now,
yes,
when you talk about brine, this is also known as concentrated sodium chloride. Are we there?
Yes, sir.
Now, in the solution, we have sodium ions, chloride ions, hydrogen ions, and hydroxide ions. Are we there?
Yes.
Now, what is coming to the when you talk about the cathode now? What will be coming to the cathode will be the sodium ions and the hydrogen ions. But from what we have discussed today, we see that hydrogen is lower than sodium. Are we there? But don't forget that this is concentrated, meaning that if it is concentrated, meaning these ions for water, these ones are from water, isn't it?
Yes, yes.
These ones are from water. If it is concentrated, these ions from water means that they are less in concentration. So if they are less in the concentration, the sodium ions will be preferentially discharged compared to hydrogen, even though hydrogen is more reactive, but its concentration is low. So these ones are the ones which are present in a high concentration.
Okay,
and I believe,
sir. It's very clear.
Yeah, and I believe when you are looking at that, they say that sodium ions are preferentially discharged because they are higher in concentration than hydrogen ions.
Oh, okay.
Yes, here
yes,
they want.
I understand.
Yeah, in that case, they use the word concentration.
Concentrated. Thank you very much, sir. I've understood.
Okay, you're welcome. Let me see whether we still have someone with a question. Tekino KL5.
Sir?
Yes, please.
I wanted you to first help me with, like, I've not got the definition of electrochemicals clearly.
Electrochemical cells.
Yeah, I've not got it clearly.
Okay, you write it. You write it down. Let's write it down now. Maybe I read it. I read it slowly by slowly, and then move on very fast. Do you want? Let's start with reactivity cells.
Okay.
So we're saying that reactivity cells is a list of metals, arranged from the most reactive to the least reactive. A list of metals arranged from the most reactive to the least reactive. That is what you call the reactivity cells.
Yes.
Then electrochemical cells, they are saying that is a list of elements or ions, a list of elements or ions, arranged according to their standard electrode potential. Arranged according to their standard electrode potential. Their standard electrode potential. And I said that we can put an NB so that this standard electrode potential doesn't disturb us. You put this NB so that we can note it down. Are you there?
Yes.
This put NB and say it shows the tendency to gain or lose electrons. It shows the tendency to lose or gain electrons under standard conditions. Under standard conditions. It shows the tendency to gain or lose, the tendency to gain or lose electrons under standard conditions. So that is the one that we have been talking about.
Okay, thank you, teacher.
Okay. Welcome. Kiala, are you having a question, Kiala? Kiala,
Yes, teacher.
you have a question?
Yes, teacher. Good
Yes.
afternoon, teacher.
Good afternoon.
No, teacher, I just want to inquire because I think I'm
Mm.
lost here. Is
Mm-hmm.
potassium another word to mean as potassium, or potassium is another element itself? Because I'm seeing here you have written potassium.
Hey, oh, sorry. This is supposed to be potassium. You can see it in the symbol is
Yeah,
K
that's why I
plus, yeah?
was confused. Yes, thank
Yeah,
you, teacher.
thank you. Yeah, that shows that you're following very well. Now, take us through the next, you take us through number 2. Take us through number 2. Number 2 is for the anions. Take us through number 2. Hello. Okay. Jeremiah, you can take us through number 2. Jeremiah,
I had a question.
you had a question.
Yeah.
Okay, you can ask.
From number 1, the one which is preferentially discharged, it's one that forms the gas.
Oh, the one which is potentially discharged is the one which forms what?
The gas.
Now,
Like
it depends on it depends on what is being potentially discharged. You look at this. Look at if it is hydrogen and copper, isn't it?
Yes.
Are we there? Copper,
Yes.
meaning copper will be potentially discharged, isn't it? Now,
Yeah.
if copper is potentially discharged, it means that you're removing this positive 2. And this positive 2 means that it had lost 2 electrons. So for us to remove this charge is by giving it back its 2 electrons. If it loses those 2 electrons, what will it form?
If it loses
it will form copper. It will form copper,
Yeah.
isn't it? And copper is a solid. Are you seeing?
Yeah. Yes.
So these metals, when they are discharged, they form solids. But it is only hydrogen, which is a gas, which when it is discharged, it will form a what? A gas. You get?
Okay.
You have understood
I've
that?
got it. Yes.
Yeah. Now, you recall that one was for anions. Now, I want us to look at briefly the reactivity cells of the anions. These ones which are negatively charged. The other ones were cations which are positively charged. So these are some of the common anions. Of course, we are not putting all the anions, but now we look at the ones which are very common in different compounds and the ones which are common when we are doing electrolysis. So the most common ones are already shown in the table. So we have number 1, sulfate, we have nitrate, we have hydroxide, then halides, where we have chlorine, bromine, and iodine, then iodide, though we see iodide coming, which means between chlorine and bromine, they are somehow higher compared to iodine. Then let's look at this. These ones are 3: chlorine, bromine, and iodine. Now, these are 3. Between the 3, which one is more reactive than the other? So we see we are having iodide ion, we have bromide ion, and we have the chloride ion. So that is if we have the 2 halide ions at the same time. But the reason why we had put them together here is that most of the time you'll find that it is either a chloride ion or a bromide ion or iodide ion, which is with maybe a sulfate, or it is with what? A hydroxide. So that's why you may not find that they are all together. But if by any chance they are all there, then we arrange them according to this. The iodine first, followed by bromide, followed by chloride. Which means between all the 3, chloride is the least reactive. And we have a simple rule also here. Just this rule is just coming from what we have from the table, that sulfate and nitrate ions are never discharged. Instead, hydroxide is discharged at the anode, producing oxygen gas. So why do they put they are never discharged? Most of time, if you find that is aqueous, meaning if it is aqueous, meaning that substance has been dissolved in water. So in one way or the other, you will find that we have hydroxide ion. And we are seeing that the hydroxide ion are lower than the sulfate. They are lower than the nitrate, meaning that for them they may not be discharged because they are higher than the hydroxide. So that's why we are saying that most of the time you'll find that it is hydroxide which is discharged at the anode, producing the oxygen gas. But there is also something to note, that for halides, halides are discharged preferentially over hydroxide. Why are they? Because they are lower in the reactivity than the hydroxide. So they are preferentially discharged. If you have hydroxide and chloride, or hydroxide and bromide, or hydroxide and iodide, it will be the halide which is discharged preferentially. Why? Because they are lower. The reason why we are putting this NB is to help us just to have it in our mind that even if you don't have this table, these are very clear. These 2 points are very clear to remember. That if you sulfate and nitrate are never, it is hydroxide. But the halides are preferentially discharged than hydroxide. Unless there's someone with a question. Jeremiah, you can mute, and we see Nusula has a question. Nusula?
So me, I'm inquiring, what are halides?
Oh, halides. Okay, maybe let me have someone to answer that. Nusula, you remain on the call. Someone is going to answer you here. Aria, can you answer? What are halides? Alia? Ria? There's Alia and Ria. Any of you can unmute. Yes, Alia.
Good afternoon, sir.
Good afternoon.
Actually, I also had a question.
Okay.
Okay, let me first answer that.
Halides.
Halides are binary chemical compounds or ions containing a halogen atom paired with a less electronegative element or organic group.
Okay. So there's one thing that you have talked about, a halogen, isn't it?
Yes.
And the halogens, we know them. These are group what? Group 7 elements.
7. Yes.
So group 7 elements we have, number 1 is what? Fluorine, you go to chlorine, you go to bromine, and so on. These are the common ones, at least that we normally use. Now, okay, even iodine. Let's not forget about iodine. So we're saying that these are the halogens. So when these halogens, they are in ionic form, they are no longer, we are not calling them halogens. Instead, because when you have them in form of ions, meaning now they are joining with other substances to become stable. Because the reason why substances form ions is for them to become stable, isn't it? So which means when they are bonded to other substances, they form ions. And these ions are forming, now we call them the halide ions.
Ions, yes.
Yes. I believe that is very clear to Nusula. Nusula, is it clear?
Yes.
Okay, good.
Okay.
Yes, Nadia,
Then
now
my
you have.
question. I'm a bit confused about the the ions that are preferentially discharged? Is it the ions that are are last in the series?
Yes, the ones which are, and you recall, you look at this table. Are you seeing this table now? When you look at this table,
Yes.
these ones have been organized from according to their reactivity. Yeah, from the most to the least reactive. Are we getting that?
Yes.
Now, the ones which
Yes.
are more reactive, they are least discharged. While the ones which are more reactive, they are mostly discharged or they are preferentially discharged. So the ones which are preferentially discharged
Oh,
are the ones which are least in reactivity
list.
or least, yes, which are lower.
Okay.
Just giving you
I
like
now
a
get.
simple example. Like a simple example here, if in the ions we have nitrate and hydroxide, and we want to know which one is going to be discharged at the, they'll go to which electrode? They'll go to the
Uh,
anode.
the anode.
Anode, because anode is a positive electrode, meaning the negatives will come towards it. Yeah.
Yes.
So between the two, which one is going to be discharged?
Hydroxide.
It will be hydroxide. And why? Because it is lower in the
Low in
reactivity,
the sorry.
yes, than
Sorry.
nitrate.
Nitrate.
Okay. Mm.
Yes, sir.
And there's something that we have seen that when hydroxide is discharged, it produces what? Oxygen, gas, and
Gas.
water. Okay, anyway, they have put just oxygen gas, but also it produces water.
Water.
That is something that we need to put in our minds, that when you're discharging it, you don't just discharge it like any other halide or any other substance. Okay.
Okay.
Before you go, so here is the summary. So the summary, they're saying that summary of electrolysis discharge preferences. And they're telling us that at the cathode, hydrogen ion is discharged unless a less reactive metal like copper or silver is present.
Present.
But
Yes.
also, don't forget the one Jeremiah talked about when it is brine. If
Brine.
it is brine and that is concentrated sodium chloride, that there it becomes a different case, because you'll be having few ions for hydrogen in solution, and therefore the sodium ions are the ones which are going to be discharged. But that one is for special case, isn't it? That is for the special
Yes.
case. But if it
Okay.
is in aqueous solution, this is the conclusion that we have, that hydrogen ion is discharged unless there are less reactive metal ions like copper and silver. The reason why you're putting copper and silver, those are the common ones. Surely they are the common ones that we normally interact with during the electrolysis. So the ones you have seen that I have presented today, the anions and the cations, those are the common ones that are majorly used during the electrolysis.
Electrolysis.
Then at the anode, they're telling us that hydroxide is discharged unless the halide ions like chloride, bromine are present. Because we have already seen that these halide ions, they are lower in reactivity than hydroxide. So if they are present,
Hydroxide.
they will be the ones to be discharged. But if not, it will always be hydroxide, because they said for sulfate and nitrate, for those ones, they are never discharged, because you can never have nitrate and sulfate ions which are present alone in the solution.
Yes.
When they are there, they must have been maybe dissolved in water. And if water is there, therefore we have the hydroxide ions.
Ions.
I believe that one is now clear to us. That's what I wanted to share with
Yes.
us about the one which is preferentially discharged and the one which are not preferentially discharged. And I've taken you through the anion and the cations. Maybe even this document, I'll share it in the group alongside the other PowerPoint presentation, so that they can also be, you can have them all together for further discussion.
Okay, thank you, sir.
Okay, welcome. So there are key points I want us to go through about electrolysis, but of course we have not finished electrolysis of because we still have for copper sulfate and sulfuric acid and lead bromide. Those ones we're going to see how to summarize them. Let's not worry about that. So electrolysis, we have seen that electrolysis is redox. Electrolysis is redox. Why? Because during electrolysis, there is oxidation taking place and there is reduction taking place. So in simple terms, electrolysis is redox. Because we have seen that even in the overall reaction, we end up with a redox reaction. So electrolysis is redox, where we have oxidation taking place at the anode, and we have reduction taking place at the cathode. Then we also have our memory trick, which I've been singing all along from the beginning of this topic. I've been singing this trick of ours, oil rig, where we say that oil is oxidation is loss, reduction is gain. So if you have forgotten at any point, just know that oxidation is loss. Loss of what? Electrons. So if anode is taking, at the anode you're having oxidation taking place, meaning we are having the loss of electrons there. If at the cathode reduction taking place, meaning there is gain of electrons at the cathode. So that is something I wanted us to look at. Let's go through application. Why is electrolysis important? Why is it important? That is the real life application of electrolysis. Real life application of electrolysis. I'm going to request one person to raise up the hand and you take us through. You can choose the one you're going to take us through. Are you going to take us through number 1 or number 2? Because we still have more applications. Let me see the one who is ready. Okay. Okay. I want someone who has not yet spoken yet. Mariam. Let me start with Mariam. 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 Let's be faster now. Yes, Mariam.
Hi.
Hello.
Real life application of electrolysis. Electroplating. Electrolysis is used with objects with a thin layer of metal like gold, silver, or chrome to enhance their appearance, prevent corrosion, or reduce wear. Common items such as jewelry, kitchen utensils, and carpets are often electroplated.
Can you help people understand what electroplating is?
Okay. I think electroplating is like what should I like when you coat something with a metal, like what should I call it? It's like galvanizing or something like that. Where you coat a metal with another metal to prevent it from wear and tear, rusting and stuff like that, because it's going to be used under conditions that may require it to, like rust and things like that. So according to this piece of the work, electroplating, I understand it like that, because layer.
Yeah, thank you. I think that is very good. And actually here on the side, they're trying to show us the electrolysis taking place, the copper plating here. This is the full electrolysis circuit, where we have copper anode, that is electrode, and we have the silver cathode, and they are doing the electrolysis. We can see somewhere they're telling us, maybe let me increase something small here. So when you look at this picture here for electroplating, we can see when you complete the circuit, the oxidation is taking place at this point, and then there is reduction taking place at this electrode, and then this is copper solution, copper 2 sulfate solution. Copper 2 sulfate solution is our electrolyte. So what are they trying to do? Copper plating, which means at the end of it all, copper is going to move towards the silver electrode, which means silver now is going to be covered by the copper. So that is the electroplating, which they're talking about, coating and a substance with a layer of another metal, which may be having better, maybe it is even more resistant to corrosion, or it may not rust very fast compared to the original substance which is there. So that is the electrolysis which is being depicted in that picture there. Let me hope that one is very clear. Then we can go to the next thing, which is water purification. Someone is ready? Let me see. Okay. Oh, this is nice. I'm seeing many people here. Kanzaire Bonita, followed by Nanyonwa Frederick. Say,
Water
Bonita.
purification. Good afternoon, sir.
Good afternoon.
Water purification. Electrolysis is used to purify water by breaking down contaminants or harmful substances.
Okay.
It can also be used to produce hydrogen gas for clean energy.
It can also be used to produce hydrogen gas for clean energy. Do you think you can explain for us something small?
What I know about water purification, it is the process of removing harmful substances from water to make it safe and suitable for drinking and other use.
Okay. Yeah, so on the side there, they are trying to show us how electrolysis can be applied during water purification. So I believe from this picture, if we have gone through that process of water purification, we can be able to see that we can apply actually the electrolysis in the water purification. This part we are on now is to help us understand where we can always apply this that we are learning. Because it's not good for us to learn things that we're not going to apply in our day-to-day life. So this is another area where we can apply in our day-to-day life. So every area, we find that I'm showing the real-life application in a picture there. Continuation there, we have number 3. Who is ready to take us through number 3 and explain for us? Okay, Bonita, you can mute, and then you have another person. Gemma. Hey. Okay. Alia, you have, yes, Alia. Alia, we can move on faster. Alia. Hey, Alia has gone off. Teddy. Yes, Teddy.
Battery charging.
Hey, you increase on the volume.
Battery charging.
In
some types of rechargeable batteries, electrolysis is involved in the process of recharging, especially in the batteries that rely on chemical reaction to restore and release energy.
Okay. Do you think you can explain for us something small there?
No, sir.
Okay. So in a here they are just trying to show us how we can do battery charging, and this is where we are applying electrolysis in battery charging. And they're saying that in some types of rechargeable batteries, electrolysis is involved in the process of recharging. Now, you recall that in the process of recharging, you recall that when you put your battery to charge, where you're putting it, it's like when you put your battery there, one side is having a positive and the other one is having the what? The negative. You always check on your batteries. Now, where there is a positive, you recall that's where it is we have the anode, and therefore we shall be having reduction taking place. Because at the anode we have, okay, is it that's why we have oxidation taking place. And then where there is negative, that's where we have reduction is going to be taking place, because the positive is attached to positive electrode and the positive side of the battery is attached to the negative electrode, which is the cathode. And when you complete the circuit, there will be flow of current, and also when you have another power source, you'll find out that this battery at the end of it on, it is rechargeable. It is now having full current it is supposed to be having. So you are seeing on the picture there, we have the DC power, the direct current, the battery charger, and when they put it on, they are showing us that there is a flow of electrons when we switch it on. The flow of electrons between the one they were charging and where we are charging from. So there will be that flow of electron, and of course, where we have a flow of electron, we shall also have the current flow in the opposite direction. So we can see at the end of it all, we shall be having reduction taking place, we shall be having oxidation taking place, and we already said that electrolysis is redox. Electrolysis is redox because we saw that electrolysis involves oxidation and reduction reactions. Okay, we can move on to Teddy. Thank you very much. Let's go to Gemma and then finally to Leah. Hey, Gemma, Leah, and then Timothy.
Yes, sir.
Leah, take us through number 4. Number 4 is there. Yes. Hey, it has gone off. Gemma, are you still on?
Yes, sir.
Yes, take us through in 1 minute.
Okay. Extraction of metals. Electrolysis is used to extract metals from their ores, such as aluminium, from
Bauxite.
bauxite.
Okay.
This process is essential in the manufacturing of products like aircraft, aluminium foil, and kitchenware.
Have you made research about our next topic, industrial processes?
Master, not yet.
Oh, not yet.
Not yet.
This topic is getting done today, and our next lesson will be about industrial processes. In industrial processes, that's where we're going to see application of our electrolysis. For example, in the one they're telling us here, the electrolysis of aluminium. When you are forming in the manufacture of aluminium, we shall be able to see that we are going to apply electrolysis. We shall be able to see that electrolysis is very much applied in extracting these metals like aluminium from its ore, which is the bauxite ore. And here is a diagram which I believe we shall be able to look at when you're looking at our next topic. But let's go there. Before we reach on a given topic, you should have made some research, which means before we finish first term, make sure that you are going ahead and you do research on the upcoming notes. That's why we have spent enough time on oxidation and reduction, because I know once you understand it very well, we shall apply the same knowledge in our next topic, which is the industrial processes. So now I want
Sir,
us to, yes, please.
when are we having the next lesson?
On Monday. On Monday, you'll be at school?
No, not yet. But
Yeah.
in the holistic group, Mr. Kaziba said we are extending for only 1 week, so I'm not understanding.
Only one, because the government extended the days for reporting back, which means it is only 1 week. This coming week, the other week students will be back at school.
So are we having lessons up to next week?
Anyway, Mr. Kaziba will give us the announcement. But whether it's
Okay.
there or not, the good thing, we shall continue sharing, and we shall be putting those other lessons there for us to keep on updated. Yeah.
Okay,
It's
sir,
all right.
thank you.
Welcome. Now, I'm ending at 4 industrial applications. We have looked at extraction of metals. We have looked at battery charging. We have looked at water purification. We have also looked at electroplating. So you can see how important this process that we are talking about is very essential and crucial in our day-to-day life. So someone the other day when we were starting a topic, someone was saying, how can they set a topic on such a, how can they set an item on such a topic? You can see that there's an item which was set one time about extraction of aluminium. The other year, 2024, they said about copper, extraction of copper. And even extraction of copper involves electrolysis. So you find out that this topic is very important for even the upcoming topics. Now, there's this research I gave us to do. Let me hope we have done enough research, and we are going to use the remaining 20 minutes or 30 minutes, maybe all 10 minutes to complete. We want to make sure that we have maximized this topic very well, and we finish the electrolysis of copper to sulfate, we finish electrolysis of lead to bromide, and electrolysis of sulfuric acid. We already looked at the one for sodium chloride. This one was finished. Now we are looking at that. But you recall the one we looked at for sodium chloride, it is for aqueous solution. When you talk about for brine, which is concentrated sodium chloride, that one we shall look at it in industrial processes. We shall look at it in industrial processes. So don't worry about that. We shall look at this in industrial process, but what we have looked at is for aqueous solution of sodium chloride. And today, I want us to discuss about copper to sulfate. We discuss about lead to bromide. We discuss about sulfuric acid. Who is ready to take us through copper to sulfate? Martha, unmute. Yes, Martha? Martha, are you ready to take us through?
Yes.
Okay. The good thing, I have guiding questions here. Don't worry. I have some guiding questions which are going to guide us. So we have this, which is going to guide us a lot. So here they are saying investigating electrolysis of copper to sulfate solution using carbon electrodes. Okay. So there is a link for the video, but instead of giving you the link, we are going to watch that video immediately after, maybe after you telling us something. And the video we are going to watch, we have used pencil leads. We have used pencil leads because last time many people are saying, how can we do this at home? So instead of using pencil leads on copper to sulfate, since you have sodium chloride at home, you'll do that one for sodium chloride. But we shall be able to watch that video. Okay, take us through that one.
All right. So the electrolysis of aqueous copper to sulfate. Investigating electrolysis of copper to sulfate solution using carbon electrodes. What you need: 4 batteries, circuit board, glass breaker, copper wires, a switch, copper to sulfate solution, and graphite electrodes. Crocodile clips, retort stand, and clamp.
Okay. Is that clear, or there is something you can tell us whether that one is clear, or you help people understand what you're seeing in the picture?
So what I'm seeing in the picture, according to what we are to maybe those like what we are doing in physics.
Okay.
Yes. You notice that like, okay, let me just hint a little bit on like what we know from physics is that chemical energy from in electricity we have the electrolyte, which is in this case our acid.
Electrolyte?
Yes, which is our
In this,
acid.
which acid is that?
Our sulfuric. Sorry.
What is our electrolyte today?
Our copper 2 sulfate solution.
Very good. So copper to sulfate solution is our electrolyte. That is good.
Yes. So
Okay.
you notice that, our rods, our carbon rods, our electrodes are put into this acid.
It is not acid, it is copper what? Copper to
Solution.
sulfate. Yes.
Sorry, yes, into that solution. You notice that they produce energy.
Okay, they will produce energy. Now, what we're going to do today, and what you're going to take us through, is to help us understand what happens during electrolysis of copper to sulfate. We have seen that we have this, and by the way, when we look at these lines which are having angle of 90, we start wondering, how can I do this? But these are just wires. These are the copper wires, these ones here. These are the copper wires.
Yes.
Now, these copper wires, it's not a matter that they have to be very straight, they have to be one. But of course, for the case of drawing, we just draw them and in that manner, and then we become somehow neat. But doesn't mean that now it has to be very straight like that. We shall be able to see. Now, where we split a negative and positive, this is our power source. In this case, we said we are using the what? The batteries. Depending on the way you arrange your batteries, so long as we see 6 volts. 6 volts, I believe those are 6 batteries, since each battery has 1.5 volts. Then we have our carbon electrons or graphite electrodes. We have our electrolyte, and then we can be able to start. So let's look at what to do. I believe what to do is very clear. That arrange the materials provided as shown in the figure. Then ensure that graphite rods do not touch each other. Are you seeing this? We make sure that they do not touch each other. I believe in the other picture you saw that even when they are doing this, there's something they use to separate. If you can be able to see. Are you seeing here? Hello? Whom am I moving with? Martha. Martha? Martha? Yes. Martha? Martha, are you still there? Okay, Martha, I think she has disappeared. Let me move with someone. I want to make sure that we are moving together. Who else can we move with? Melvin?
Yes, sir.
Okay, let's move together. So I was asking, are you able to see what in this video they are using to separate the electrodes?
Yes.
Yeah, so here they are using, just being creative. You use this paper here to separate the electrodes. So they are saying that we have to make sure that electrodes do not touch one another. Then they're saying close the switch for 5 minutes and note down your observation. Remove the electrodes from the solution and observe any changes on them. Now, during this electrolysis, Melvin, tell us.
Yes, sir.
There's number 1. Look at number 1 and you answer. Read for us number 1 and then you respond to it. A good thing we have looked at. Okay, I want it to be very clear. Number 1. Are you seeing number 1?
Sir, first put back up. Yeah, I'm seeing.
Okay, sorry about that. I think it was some error somewhere. But Melvin, are you still there?
Yes, sir.
Okay, take us through now part N.
Identify and write the chemical formula of all the ions present in phosphate solution.
Okay. Tell me. Identify. Read for me as I write.
So we have the copper ions.
Copper ions. Continue.
Sulfate ions.
Sulfate ions. Continue.
So I think also the hydrogen ions.
Where are they coming from?
Because it's copper to sulfate solution. So meaning water was added to make it a solution.
Okay, good.
So I think also the hydroxide.
And also the hydroxide. Very good. So because it is a solution cannot just come about, which means they got copper to sulfate and they added water to make the copper to sulfate solution, meaning we have copper ions and sulfate ions coming from copper sulfate, and then the hydrogen ion, hydroxide ions, which are coming from the water. Good. That is nice. Let me have another person. Thank you, Melvin, for leading us. Let me have Kagenda. Melvin, thank you. Now Kagenda. 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 Okay. Kagenda is not unmuting. Jeremiah.
Yes.
Take us through.
So part B, write the half equation for the discharge of ions at the cathode. So at the cathode, the cathode is negative, so it would have attracted the positive ions of the copper ions and the hydrogen ions. So it will discharge the copper ions because they are lower. So the copper ions will be preferentially discharged, and the equation is copper copper plus the 2 electrons to give us copper as a solid.
Which type of reaction is this?
It's a oxidation. No. Yeah, no, reduction.
It is
reduction.
Reduction
Yeah.
because we see gain, yeah?
Yes.
Because there is gain of electrons, therefore we say it is reduction. Oh, that is nice. Think there we're moving on very well. Let me have Rengo also help us in another part. Thank you, Jeremiah. Rengo. Then Ria will be the next person. Rengo. What is the half equation at the anode, Rengo? Rengo is not speaking. Ria, you also unmute.
Yeah.
Ria.
Yes, sir.
Take us.
Java scroll twice.
Take us through like the way Jeremiah has led us. We get to know which ions are coming. Okay.
Teacher, let me see the
Up to
ions
there.
up.
Are you seeing them now?
No. Yes.
You're seeing them?
Yes.
Ria? Hey.
Yes, teacher.
Ria, you can't see. Hey, what's the problem?
I'm seeing.
What are you seeing now on the screen? Are you seeing now?
Yes.
Okay.
So, teacher, and the anode is.
So, can you take us
The
through
anode is.
part 2 on anode? Which ions?
So the anode is positively charged. So, there will be there will be sulfate ions and the hydroxide ions.
Okay.
Yes.
Then, which ones will be preferentially discharged? Which ones?
So the hydroxide ions will be
We already
preferentially
have now
discharged.
sulfate ions and hydroxide ions.
Yes. Then the hydroxide ions will be preferentially discharged because they are less reactive than the
So they will be
sulfate ions.
preferentially discharged, and we say that when they are preferentially. So which half equation do we form?
The hydroxide ions will.
What does it form when it is discharged? Which products do we form?
I'm not sure.
Okay, Aria, you help her. You remain on. Then Aria, unmute. Aria.
Yes.
Okay, so we said from up there that when hydroxide is that Aria.
When
Aria, which products do we
hydroxide
get when hydroxide is being discharged? discharged?
We get oxygen and water. Hello?
We form
Water and oxygen.
oxygen and water.
Water.
And
Yes.
yes, we are getting. So when you get oxygen and water, you record that we are. So electrons, is it gaining or losing? So is it gaining electrons or losing electrons?
Losing.
So which means we shall be having an electron here because it has because when you so when it loses one electron, instead of putting here minus electron, we can bring it this side, we say plus electron on the other side. But is this equation balanced? This equation is not balanced. Are you seeing that? So we can balance it, and we put what can we put to make it balanced? Put a 4 here, and then we also put a 2 here. That we have 4 hydrogens, and also this side we'll be having 4 hydrogens, 4 oxygen atoms, 4 oxygen atoms, and then we have also 4 electrons. And then we have our equation complete.
Sir.
I hope that one is very clear.
Teacher.
Okay, can I? Yes, please.
I don't know whether it's.
Yes, please. Are you getting me? Yes, I can hear you. You can speak. Yes? Hello? Okay, what is the issue there? Okay, let me hear from Jeremiah. You unmute, I get to know whether there's a problem. Jeremiah? CEO Robert.
I think because like we can't see.
Okay, you unmute and you first tell us whether is there any issue or
No, teacher, there is no issue.
you can't what?
Okay, teacher, you're breaking, and at some point we weren't seeing what you are writing.
Hello?
But I think it's better now.
There's no issue. Okay, so
Okay.
I think these people are having some issue. Okay, is the equations are clear now? Okay, can I know where we have any question or we go to just to part C? Let's move on to part C very fast. Because part C is just saying describe the electrolysis of aqueous copper to sulfate, which I believe we have already discussed from up there. Unless someone has a question on electrolysis of copper, there we can answer that, and then we go to lead 2 bromide and we wind up with sulfuric acid, where you're going to use very few minutes. Okay, let me hear from Alia and the CEO, Robert. Alia, what are you saying?
Okay, I was just saying that.
Okay, CEO Robert, what are you saying? Okay, good. They're putting down their hands. Alia, any question?
Okay, the thing is that I don't know whether it's my network or yours, but
You are just saying that what?
I don't know whether it's my network, but your words
So,
are
Alia, I think there is a
breaking,
problem.
and hello.
Okay. But can you hear me now? I can hear you. I don't know what you need to check that side. I want us to see whether Alia, can you hear now? Hello. Okay, sorry about that. I think it is the network here which has been disturbing. Okay. Melvin, you unmute now. Melvin? Melvin?
Yes, sir.
Yeah, I think network was a challenge. Let me hope now we can be. Melvin?
Yes.
Are you able to see the screen?
Yes. But now it's off.
Okay. Okay, I just want to make sure that we have. I want us to watch this short video showing the locally available material. I want to be sure that you're seeing what is going on, and then we can move on to something else. Melvin, are you seeing on the screen?
Yes, sir.
So here there are no ones. What we need to see, what we are looking at is copper 2 sulfate electrolysis. So let's just let us watch, and then we see what is happening. It's exactly what we have been doing. But I want us to see how they have used locally available materials to do this process. So if there's any issue, don't hesitate to speak. You're the one whom we are moving with now. So at that point, they are dissolving the copper 2 sulfate. Okay, Melvin.
Yes, sir.
I believe it was very clear. And one thing I wanted us to observe here is to see that actually we can use even our pencil leads to do this process of electrolysis, and these pencil leads acting as our copper electrodes. I don't know whether you had a question on this, and then we can move on. Do you have
Sir,
any
I
question?
just wanted to ask. Yes.
Yes, please.
Will there reach a point when they tell us to balance those equations?
Oh, now balancing equation, you recall this is one area that we are taught, especially when we reach on more concept in senior 3, we look at balancing equations. So it is very good for us to always balance equation. When you write an equation, write it when it is balanced. But of course, yes, so writing a balanced equation is very good, especially when you're doing the industrial processes. You'll find somewhere they want you to write equations, though if you don't know that equation, you can always use also the word equations. But now here, Can we write this one in word equation to look bad? Yet we can just write it in this manner, and then we balance our equation.
Okay.
Yeah. Any other person
Okay.
having a question? Okay, I believe now we can run very fast. Okay, I see someone here. Nusra, unmute. Melvin, you can put down the hand if we are done so that we can know who has a question.
Sir,
Yes.
in the procedures, you say that ensure that the graphite rod do not touch each other. And my question is why?
Oh, now, Nusra, before I
Yes.
answer you, can I have this person respond to you here? There's someone here who's saying, Atrik. Atrik, can you respond to Nusra? Atrik. Atrik?
Okay,
Good afternoon. Your network, Atrik, is not clear. Atrik, your network is not clear. Okay. Ria, you respond.
Teacher, why they should not touch each other?
Yes.
I think they wouldn't be discharge. They wouldn't discharge well if they were touching each other. That's what I think.
Okay. Now, you look at this. You recall we say that these are conducting electrodes. Are we there? You look
Yes.
at this. If we have this solution, this is maybe our copper sulfate solution. And then we are saying that these are electrodes. This is electrode, and also this one is a what? Electrode. But we are saying that this electrode should not touch this electrode. Why are we saying they should not touch one another? Because you recall here we have our power source, and maybe we have our switch somewhere, and then this one also comes up to here. So when we complete the circuit and we put on the switch, which means the current is going to flow maybe from this electrode A through this solution. Are you seeing that? Through the solution to electron B. This is our electron B, and then it continues in that manner. But if these ones are connected to one another, you recall they are conducting electrodes. They will complete the circuit, which means the current will not first go through our solution, the electrolyte here. Husna, are you getting this one?
Yes.
So because now you look at this, if we have this electrode here and it comes in one way or the other, it touches this, which means electrons when they are flowing, they are just going to flow from this side. They just pass here, this electrode, then they'll go direct to this instead of passing through our electrolyte. Because one thing you want to know is whether our electrolyte is going to conduct current. And the only way we can know that it's conducting current, it is when these electrons pass through one electron, they go through these ions of the electrolyte, they go through this one, and then it continues in that manner. So when we join them together, meaning we shall not get our what you're looking for, we shall not be able to get it. Why? Because we have already completed the circuit, and therefore current will not first break down these ions which are present in the electrolyte. That's why we see even in this one, looking at this, let's look at this 1 minute just. So that is our copper sulfate. We are adding water to dissolve it. After dissolving it, we stir so that can completely dissolve. So, Husna, are you seeing that?
Yes.
So that one, that white soft board they are put is to help in separating. Otherwise, when this one attaches to this, they will just conduct electricity because they are all conducting loads. So when you join them, it will not first pass through the solution there. So that's why we have to make sure that we separate them.
Excuse me, sir.
Yes, please.
I have two questions. The first one is, why do the ions have to be broken down in the electrolyte? And the second one is, how are those rods of a pencil, how are they adapted to conducting electricity?
Before you close, is that Ria who is asking?
Yes, sir.
How are these ones connected to conducting electricity? Josiah Kizito is answering. Yes, Josiah Kizito. Hey, we are already in our extra time. Okay. We need to wind up. Kizito?
Yeah, so I'm answering the question as to why graphite is able to conduct electricity. So it is mainly because the atoms in graphite, the particles in graphite, all of them are not bonded to each other. Like it takes a carbon, graphite is an allotrope of carbon, and it takes a carbon to bond like to 4 electrons to become how can I say this, like fully bonded. But I think for graphite it's either 3, if I remember well. So it has
Yes.
one electron that can easily conduct the electricity.
Okay, thank you very much, Kizito. So Ria, the reason why pensolate can easily conduct electricity is because of the presence of free mobile electron. If you recall very well the structure of graphite, it is arranged in a way that the carbon atom has one electron which is not bonded, and that one, for each carbon atom, those electrons are the ones which are free to move and thus conducting electricity. Maybe Regina wanted to also add. Yes, Regina. Hey, Regina.
Yeah.
Regina?
Okay. Good
I
afternoon,
think
sir.
Ria. Good afternoon.
I want to talk about van der Line forces.
Yeah.
Sorry, van der Waals forces. The electrodes of graphite. How like they can easily slide over and all that when it's conducting.
Okay. Yeah, so from the other structure of graphite, we see they are held by those van der Waals force of attraction, but also one major thing of conducting electricity is due to those mobile electrons, which are present right away from the structure of graphite. I believe we can move on and we get done with this topic today. And one thing I wanted to show us is just something small, just the highlights, because I know I'll be able to share with you this. But when you look at investigating electrolysis of lead to bromide, this is lead to bromide, which can also be written as lead bromide because it is 2, which means it has a variance of 2, meaning it has Br2. So that is our lead bromide. So here is our setup. Here is our setup. I want someone to raise up the hand. Look at this structure very well. Okay, this setup. I want you to identify for me which name is given to this electrode. Which name is given to this electrode? What happens to that electrode? We have equation at that electrode. Which ions are present in the solution? Then if we are done with that, we shall be getting done with lead to bromide by show of hands. Oh, no one is putting up the hand. This is lead to bromide. I want us first identify the electrodes. Which one is electrode A? Which name is given to electrode A? Which name is given to electrode B? Yes, Teddy?
Trying.
Okay.
Electrode A is a cathode.
Is a cathode. Okay.
Yes. Electron
Why?
B because it is a positive, a negative.
Negative electron. And also another area you can always see. You see this wire. Are you seeing this wire?
Yes.
It is attached to this short bar. It shows the negative terminal of the battery. This long bar, it shows the positive terminal of the battery. Electrode attached to the negative terminal is called the cathode. The one which is attached to the positive terminal is the one we call the anode. Good. Now, Teddy. Maybe Teddy and Alia, we are going to move together and we finish this very fast. Alia, also unmute. Any other person ready, you can also raise up your hand and then we can move together. Okay, let me move with those two and then a trick will also take us through. Now, Alia,
Yes.
can you tell me the ions present in this solution of molten lead bromide?
Yes.
Which ion? The ions present. Which ions are present in this lead 2 bromide?
Bromine and lead.
It will be lead ions and the bromide ions.
Bromide ion.
What about hydrogen ions? Don't you have hydrogen ions?
No, because it's because this is molten lead to bromide.
So
In
it is
simple terms,
molten.
just to become liquid.
Good. So which means they're just heating. You can see in some heat source here. They are heating it to melt it to form a liquid. So there's nothing like water, meaning we have only lead ions and bromide ions. Okay. Another question. Which ions are discharged at the cathode? Which ones are discharged at the anode? Which ions?
Bromide at the anode.
At the cathode we have?
Lead ions.
Lead ions. And then at the anode we have?
The bromide ion.
The bromide ions. Which kind of reaction takes place at the cathode?
Reduction.
You said it is?
Reduction.
Reduction. Then at the anode we are having?
Oxidation.
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 Now, I think that you have almost finished the whole process on this. Maybe what you are remaining with are half equations. Half equations, which you are going to do also at the anode. We also do half equations at the cathode. Summary, we want to summarize all this very fast. Okay, thank you very much, Teddy and Alia, for taking us through. Maybe let's have other two people to take us through the half equations at the anode and half equations at the cathode. Who is ready? Nusra and Rayton. Rayton also, Rayton, unmute. Okay. Rayton, tell us the one for anode and then Nusra, the one at the cathode.
Okay, thank you, sir.
Okay.
At the anode, the bromide gas, the bromide, it gives an equation of bromine gas and
we have lead ions.
Bromine gas, when you're writing, these are bromide ions which are going to be discharged, which means having a minus, it means that they have extra electron, which means we need to remove it. So if we remove it, which means we're going to have
they have
bromine.
and lead.
Bromine gas, and then we have an electron, but this equation is not what? Balanced. Are you seeing? Because it's not balanced, meaning we need two bromine atoms, so we have to put a 2 here. But when you put a 2 here, which means that they will need to lose 2 electrons because there are 2 atoms, meaning they will also be able to put 2 electrons. Are we seeing that?
Yes. Yes.
Right on. Have you understood that one?
Yes, I've understood, sir.
Okay, very good. Now, Nusla, take us through yours.
So at the cathode, we have lead ions.
Lead ions. Yes.
So since they have a 2 plus, that means that they need 2 more so that they become. So we shall. Yes, dash.
They need
what
they
they
need
form?
it too.
Lead.
So you form a lead solid.
Yes,
Good.
Lead solid.
Very good. Let's clap hands for all these people who have. Yes.
What of? Because for me, I'm just inquiring. For copper to sulfate, we didn't state the overall equation.
Oh, no, and because we looked at it in the first time, I wanted us to try out now these ones. Like for now here, if we want overall equation, which means we are going to just add that 2. You recall these 2 electrons, we are going to cancel. Are you seeing?
Yes.
Meaning we are going to be having 2 bromide ions added to lead ions. Then we get bromine gas. Are you seeing that? And lead. Are you seeing there? We'll be able to get our overall equation. So we have to make sure that we balance so that these electrons can easily do what? Cancel. So you go also and try out for copper. Copper. And your overall equation, you'll share it and we see whether you have passed it or not.
Yeah.
Because this is our last lesson, I don't want us to close before we just have a small glimpse on sulfuric acid, which is our last part. For lead bromide, we are done. These notes, I'll give them to you for you to just go, have a look. But whatever we have put here is what we have already discussed. You can see observation at the cathode. They are telling us that lead metal is deposited as shiny metallic solid. And then at the cathode, there is reduction taking place, where lead gains 2 electrons to form lead solid. And that is what we already have. Then at the anode, we are saying bromine gas is released, which can be identified by reddish brown color and its transient irritating odor. You can see that we even have the equation which you already have, and you can be able to see that that one is very correct. Okay, so additional observations. Okay, those ones, it's okay. We shall be able to have them. Then discussion. On the discussion, they're saying that the electrolysis of lead bromide involves breaking down lead ions and bromide ions. Lead ions are reduced to lead metal at the cathode, while bromide ions are oxidized to form bromine gas. Are you seeing that? That is what we have already discussed. Only from the diagram, we are able to discuss all these things from just a diagram, and we're able to summarize everything that is encompassed in all this work. So you see that process demonstrates key principles of electrochemical reactions, including the movement of ions in the molten state and the composition of elements at electrons. Maybe let me have one person to read for us the conclusion. That conclusion. Who is ready to read for us that conclusion? The conclusion. Okay. Wolves unmute. Unmute Wolves. Wolves.
Good afternoon.
Good afternoon.
Electrolysis of lead 2 bromide results in the formation of lead metal at the cathode and bromine gas at the anode, confirming the expected reactions based on the ionization and reduction oxidation process.
And that marks the end of lead bromide. Let me hope that one was very clear and nice for us to understand. If anyone has a question, please don't hesitate to inquire. So what has remained is the electrolysis of sulfuric acid. Electrolysis of sulfuric acid. Electrolysis of sulfuric acid. If anyone has anything you can add on electrolysis of sulfuric acid, you can raise up the hand, or I leave it for you to go and try out from wherever you are, and then we call it a lesson. Let me see if anyone has an inquiry or something you'd like to share about sulfuric acid. You share it and then we close from there. Yes, Martha. Martha? Martha? Martha, unmute. Okay. Teddy? If you don't have a question, you put down the hand so that we can wind up. Teddy, you have a question?
No, just
Or
inform.
you're adding something on sulfuric acid?
I'm just informing you
Yes, please.
that the lessons will end on Tuesday.
Tuesday when? Tomorrow?
3rd.
Yes?
3rd.
Next week. Okay. So which means next week we shall have, I'm going to summarize, we shall summarize the whole topic of industrial process next week on Monday, so that we don't have any, this holiday we have covered the 2 topics. Yes?
The timetable was pinned.
Yes, it's okay. So on Monday, we shall be able to complete our second topic of industrial processes. But I want us to finish this. Anyone who has something you can share on sulfuric acid, and then we move on. Martha, you have something?
I wanted, maybe what I want to first know is, like in the industrial process of sulfuric acid, does it have the
Yes.
same thing to do?
Does it have the same thing
Like,
to do with electrolysis?
yes.
Oh, for you call it is a different process we use to manufacture sulfuric acid. But here, when we talk about electrolysis, in this case, we are passing current through the sulfuric acid, meaning sulfuric acid is our electrolyte. Are you seeing now? This is our
Yes.
sulfuric acid, which is our
Yes.
electrolyte, and which means we can be able to know which electrode is this, basing on that. Here, electrode A, what is its name? Electrode B, what is its name? I want someone to tell me. And then we get to know what happens at the electrode A, what happens at electron B. Those are the key things that we always need to know. And then we are done with the electrolysis of sulfuric acid. So the diagrams are almost, they are the same, but where we need to be very keen is whether it is aqueous or whether it is molten. Because in molten, we don't have anything like water. But if it is aqueous, like now here it is sulfuric acid solution, meaning it is sulfuric acid dissolved in water. Maybe if I'm to ask, Which ions do you think will be present in the solution here? Yes, ma'am.
Sulfur.
We
I
have
think the ions that will be present will be for hydrogen and oxygen.
only.
And also sulfur oxide. Sulfur
Okay, you
di-
keep your. Maybe Attrick can add on what you have said. Attrick, what are you saying?
Okay, I think the ions which are present in sulfuric acid are sulfur,
Sulfur,
oxygen, sulfur, sulfur ions, oxygen
How do we
ions,
write sulfur? How do you write sulfur ions?
sulfur, that is the S. Plus negative 2.
Like this. Martha, what do you say? Okay, okay. Let me add Alia. Alia also join. Alia. Alia also join. We want to end. It is already past. Alia.
Yes.
Yes, you join. Which ions are present?
In sulfuric acid.
Now, let's look at this. When you talk about sulfuric acid solution, meaning we are having sulfuric acid itself, which is going to ionize, and this is sulfuric acid, that's how it looks like. And it is a strong acid, therefore it will completely ionize to form hydrogen ions and sulfate ions. Then, because it is dissolved in water, even water will partially ionize to form hydrogen ions and hydroxide ions. Are you seeing? Meaning in the solution of sulfuric acid, we are having hydrogen ions, which are present everywhere. So we have hydrogen ions. We have sulfate ions. We also have hydroxide ions. Are you seeing?
Yes.
Now, there's something also I want us to observe on this picture. When you look at this picture here, when you look at this power source, because this is the power supply, this long, the long line, it shows positive terminal. So since we have a positive terminal, meaning that this one will be which electrode?
Anode.
So this one will be anode. So the positive terminal is attached to the positive electrode, which is anode. Then the negative terminal of the power supply will be connected to the electrode, which is negative, and that is the cathode. Which ions are going to move to the anode from the solution here?
Hydrogen ions.
Anode is positive charged, meaning we are going to have negative ions come there.
Yes.
We are having sulfate ions and hydroxide ions. But which one will be discharged among the two?
Hydroxide ions.
Hydroxide ion will be discharged because it is lower in the reactivity. Are we there? So which means we shall be having hydroxide giving us oxygen plus water, and then we can balance our equation. We put F4 and 2. Are you seeing that?
Yes.
Then this side we are going to have, now the positive ions we have are only hydrogen. Are you seeing that?
Yes.
Meaning we are going to have hydrogen, which is going to discharge its electrons by addition of an electron to form hydrogen gas. So when you balance, we shall put a 2 there and a 2 here, and we have our equation. So because this one is loss of electron, we say there is oxidation taking place at the anode. And because this one, there is a addition of electron, here we say there is reduction taking place. I believe, and do you know that after looking at this, we are already done with sulfuric acid? You see, now we have summarized sulfuric acid. So that is how we need to keep on practicing, and so that we don't have any issue if it comes to electrolysis. Otherwise, I want to know whether we have anyone with a question, and then we have someone with closing prayer, and we end. Alia, you still have a hand up. Let me know whether you have a question, and then we move on. Okay, good. Teddy?
No, it's not a question. Maybe a
Okay.
closing prayer.
Okay, before you read us in closing prayer, let me know whether Teddy has a question.
I was just asking that, are we going to receive this work in the group?
Yes, I'm going to give it. Yeah, Mr. Kazba has it to give us in the group.
Okay, thank you, sir.
Okay, welcome. Martha, do you still have a question?
Yeah, I wanted to lead in the closing prayer after the question.
Oh, okay. Kagenda, do you have a question?
Yes, teacher.
Yes.
Teacher, I was inquiring about the group. I'm not there, so I can't receive the work.
Oh, Martha, Martha, you put
Yes, please.
the link in the chat so that Kagenda can be able to join the group. Otherwise, I want to wish you the best. Let me have Martha lead us in the closing prayer, and we end the session. Martha, lead us in the closing prayer.
Let's humble ourselves and we pray. Mighty Father, we thank you for this day. We thank you for this time, for your blessing upon us and love. And we pray, Almighty Father, for the blessing of knowledge and wisdom, and we cancel all spirits of the devil in forgetting, and we pray and believe that we'll be victors and pass our name. In the mighty name of Jesus Christ, we have prayed and believed. Amen.
Amen.
Thank you very much. Have a nice time. We meet next week on Monday.
Ani anyongera mu groups.